go to the attendance. You're going home. All right. Have a good one. All right. Well, good afternoon, everyone. Welcome back to another exciting day in mathematics. How's everybody doing? Good? All right. So warm-up number 30 is on the screen. Let's get cracking, people. Just FYI, this session is being recorded, just to let you know. Yeah, like recording. The one that goes on my YouTube channel. All right, focus, please. All right, here we go. For the sake of time, I'm going to go ahead and get started. Number one. Now, hopefully, in the past, you guys covered absolute value. Is that correct? Okay, good. Now, in case you forgot, absolute value means the distance away from zero. Now, distances, for example, if I was to ask, let's say if I was to ask Zaid, and I said, Zaid, can you go outside? And I want you to count how many steps is from here to the office. And then, to double check, make sure you count the steps from the office to here. What kind of number is he going to give me? Steps, numbers, right? But they're all positive. Is he going to say, oh, from the office over here, it's negative whatever? No, they're all positive numbers. So absolute values, such as these two bars mean absolute value. It means the distance from a number to zero. So that means that anything, look up, if I gave you this, if I gave you, let's say I gave you absolute value of -5, since the steps are always positive, or that number away from zero, how many steps is it? 5, and it's positive. Is that correct? So therefore, the answer will always be what? So what does this tell us? That the answer is what? No. In this case, it's telling us it's a negative. Is that correct? But is that true? No. So you write no solution. So anytime you see an absolute value equal to a negative, you just write no solution for that. All right, let's go to number two. Number two. I'm going to give you plenty of practice with factoring because we're about to get into a new concept coming up pretty soon. So here we go. First things first, can I divide 3 by divided by a certain number and 10 and -8? No. So therefore, and then in this case, since we have a 3 in the front, we multiply 3 times -8. That's -24. And then we got +10. That goes here. So what two numbers multiply give me -24 when you add them give us +10? No, not 6 and 4. -6. If you do negative times a negative, this should be a positive, but it's a negative. Oh. No, check this out. How about 12 times -2? What is 12 times -2? -24. What is 12 plus -2? That's +10. Oh, I got this. So here we go. Let's see if you remember what to do with the number over here in the front. What do we do with that number? We place it on top of this one and on top of that one. So we have a fraction here. Can we simplify this fraction to lowest terms? Divide by 3 top and bottom. We end up with 1 over what? 4. 1 over 4. So my first factor is x plus 4. The numerator is the x. The bottom is the number. Let's look at this fraction. 3 over -2. Can we simplify that anymore? No, it's already in lowest terms. So we write 3x. And what is the bottom number? -2. And those are my factors. No, the top numbers always are x. All right, let's go to number 3. Number 3, inverses. By now we should be experts at these, yes? Especially after yesterday's video lesson on inverses. Is that correct? All right, here we go. First steps first. Change f of x equals to y, so that is 6x plus 1. From there, we subtract 1 from each side. We end up with y minus 1 equals 6x. And then at the end, we divide by 6 both sides. We end up with y minus 1 over 6 equals x. Is that the inverse? No, we swap the variables. So we end up with x minus 1 over 6 equals y. And of course, we need to change the y to what? F of x, right? X minus 1 over 6 equals f inverse x. Go to the other one. Y equals 8x cubed. From there, divide by 8 both sides. We end up with y over 8 equals x cubed. What cancels the next cubed? It's a cube root. Cube root. So this cancels that. We're left with x on the right. On the left side, we're left with cube root of y minus 8. However, is that the inverse? No, we swapped the variables. So we got cube root of x over 8 equals y. And of course, we write it in function notation. Cube root of x over 8 equals f inverse of x. How we doing? Good? Yeah? Look at that. Beautiful. On the shirt, right, for my YouTube channel. Woo! $10 a pop. Let's go. All right, let's go to number 4. Let me make some space here. All right, here we go. All right, tell your neighbor the 5 points for f of x equals x squared. So we can start graphing that one. What are my first 5 points? Tell your neighbor, and then Alejandro's going to enlighten us. First 5 points. First 5 points. By now you should be experts at that one, right? All right, Alejandro, 5 points. -2 what? Four, that is correct. -1 what? 1. 0. 1. And 2. That is correct. So those are my first 5 points. And we label that what? F of x. All right. Next. They want us to write a rule for that. So I write our general rule. By now we know it. G of x equals a times f. X minus h plus k. We write it again. G of x equals blank times f. X minus blank plus blank, and this one is a quadratic, so a little squared. So what is A, everyone? A is 1, H is -2, and K is 6. So G of X, the 1 is invisible, we don't need to write it, so we just write F of X. Negative times this negative becomes a +2 plus 6. Turn to your neighbor, let them know where we're going to move these 5 points according to that transformation. Where are we going to move those 5 points? All right, looks like Zeke's got this. Well, let's go with Anaya. Where are we going to move those 5 points? Anaya. Left and up. That is correct. Left 2. Up 6, so we're going to be over here. And our new transformation would be up here, and we label that G of X. Is it coming back? Yes, for some of you? Yes, is it cute? All right. And number 5. last one of these. Now, I'm bringing this in because this is going to be a new concept we're going to be hitting pretty soon. Here it goes. It says simplify. We have a fraction. First things first. Check for GCF or factors. Since it's not a trinomial, I can't use Power Rangers. So what can I divide from here that I can divide from there? An x. So if I took out an x from here, I left with an x. If I took out an x from here, that leaves me with a 1. Let's do it again for the denominator. Again, what can we divide from each of these terms? An x. So we're left with x plus 2. Lastly, do you see any giant ones? And we can only do that when there's multiplication. Is there multiplication here? Yes and yes. So my giant 1 is x over x, which is a giant 1. We're going to exclude that. So what does that leave us with? X plus 1 over x plus 2. If you want to leave those in parentheses, that's fine. Now, some of you are like, or your brain is saying, Mr. Q, can't I do the x and x here as well? No, we can only do it when there's what? Multiplication. And what is this? Addition. So therefore, this is simplified. Bless you. All right, write this down. Agenda. For the agenda, we're done with warm-up number 30. Today we're moving on to radical functions. Tonight's home play, act like tomatoes. Tell your neighbor why. Yeah, some of you really need to get on that because we're about to close a quarter in a couple of weeks. Some of you are in trouble. I'm just giving you a heads up. And then we're going to be adjourned or done. All right? So, with that said, everybody got the agenda? Yes, Mr. Q. All right, so get a Cornell note ready, please. And also, you're going to need 2 graph papers. So make sure you send a gopher or come get 2 graph papers. All right, here we go. I can solve and graph radical functions. I can solve and graph radical functions. I can solve and graph radical functions. Tell your neighbor what's our new concept for today. New concept. No, that's the objective. What is our new concept? Our new concept. Radical functions. That is correct. That's going to be in the center of your prayer model. Write that in there, please. You do need a prayer model. All right. All right, so in the center you write what? Radical functions. All right, so radical functions. Radical functions. Write that in there, please. All right, definition. What are radical functions, Mr. Q? They are an equation whose rule contains a variable under the radical symbol, and there's a radical symbol. In the past, you guys used to call it the square root, but now we call it a what? Radical. So before we used to call it square root, now we call it what? Radical. So according to the definition, a radical function is an equation whose rule contains a variable under the radical symbol. So that means that inside of the radical, there should be a variable. Okay, I get it. Give you time to copy that, please. So here we go. Look up to the screen. What is the first thing you guys notice on the definition? It has to be a what? An equation. That is correct. So in order to be an equation, what comes to mind right away to make it an equation? Tell your neighbor. What comes to mind? Equal signs. That is correct. Also, it needs to have a radical symbol, also known as, what did we used to call this? Square root, or radical. However, in order to be a radical function, it has to have the equal sign, the symbol, but inside of the symbol it has to have a what? A variable. Okay. Examples. Copy those, please. Y equals radical x. 8 times radical x equals y. Y equals square root of 2x plus 1. And y equals 3 square root of x over 2 minus 6. So as you're writing those down, according to the definition, they have to be an equation. Question, do you see equal signs all over? Yes. Second, do you see the radical symbol on each of those? Yes. There, and there. Next, do each of those radical symbols have a variable inside? Yes, 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 and yes. That is correct. All right. So, students, radical functions, students. So we pretty much know what they are, right? Okay. So what are they not, Mr. Q? Well, let me show you. Before you copy those, look at each one of those three and tell your neighbor why this one is not, why this one is not, and why that one is not a radical function. Tell your neighbor, please. Why are those three not a radical function? All right? Good conversation. And I'm going to start us off. Let's see. How about mighty? Why is this first non-example not a radical function? Doesn't have an equal sign, so this is only a regular expression. That is correct. Doesn't have an equal sign. All right? Go to the next one. Why is this one not a radical function? Pass someone. Before you pass someone, tell your neighbor why that one is not, guys. Why is that one not a radical function? Pass someone, Mighty. Zaid, why is this one not? It does have a variable. It's right here. Oh, it doesn't have a variable inside of the radical. That is correct. All right. And last but not least, everyone, why is this last one not a radical function? Because it doesn't have a radical. All right. So, if you were to send this in a picture in your social media, you would tag it hashtag what? What makes a radical function a radical function? Hashtag equal sign. Hashtag equal sign. What else? Hashtag what, people? Radical. And one last thing. What is so important of the last one? Hashtag what? Variable in, and now I'm just going to write the symbol like that. Pretty straightforward, yes? Yes, Mr. Q. All right, here we go. And your graph paper at the top. Copy this, please. Focus. At the top, in the middle of both graph papers, of both coordinate planes, I want you to write general transformation rule, and then write g of x equals a times f of x minus h plus k. Have we been working with that for transformations? Yes, Mr. Q. All right. So, write that. Next, at the top left on one of your coordinate planes, I want you to write example Q, graph f of x equals radical x. Now, for the sake of time, since we have a lot to cover, we don't need our Chromebooks today. I'm not going to use Nearpod, so close those, put them away. All right, here we go. Y'all ready? Focus, please. Look up to the screen. So, to get started, we're going to graph this one, and what do you guys notice? It starts with what? F of x. If it starts with f of x, and this is a brand new concept, I want you to label this parent function. This is a new one. We've been working with 3 parent functions so far, with linear function, quadratic function, and cubic function. This is a new one. This is a what? Radical parent function. Write that down, please. Once again, reminder on those cell phones, or I'm going to take them away. All right. So, question, what do we know about radicals or square roots? Well, Mr. Q, I remember that you told us that if I take a perfect square number such as 1, what is 1 times 1? 1. 2 times 2? 4. 3 times 3? 9. 4 times 4? 16. 25. 36. 49. Dot, 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 and dot, right? So what do we know about these perfect square numbers? That we can take the square root of all of them. All of these we can take the square root. Are we there so far? All right. So, in order to graph this that has now a square root, we need a table. Just so, let me show you what the table looks like. X, copy that please. F of x. And we're going to start with the number 0. What is my next perfect square number? 1. What is the next perfect square number? 4. And I'm going to stop right there. I can go to 9, but I'll stop right there. So here we go. Some of you are like, why do you do that, Mr. Q? Because let me show you. If I substitute in here instead of x and I put 0, what is square root of 0? 0. Okay, write that in there, please. If I substitute again instead of x and I write there the what? 1. So what is square root of 1? 1. And lastly, if I substitute the 4 there, what is square root of 4? 2. All right, let's graph that. 0, 0, 1, 1, 4, 2. Graph it. Label it. From now on, guys, when I ask you to graph, look up to the screen. This parent function, which is our radical, you don't need to make a table. We use just these 3 points. 0, 0, 1, 1, 4, 2. Let me repeat that again. 0, 0, 1, 1, 4, 2. So when I ask you to graph that, you go straight to the graph and do what? 0, 0, 1, 1, and 4, 2. Okay. Questions, comments? How we doing? Yes? All right. Next, underneath that, watch what I'm going to do now. Write this down. Then transform by g of x equals square root of x minus 2 plus 3. Write that down, please. We're going to transform now using that transformation. So now look, I'm a Jedi Master. I'm going to make sure I wave my hand over here to all of you. I'm going to trigger your noodle, so watch. Look how I trigger your noodle. This is the parent function, yeah? How many points? 3. And we're going to move these according to this transformation. Tell you here where we're moving that to. Where are we going to move that to? Ooh-wee. And then 2 to the right and 3 up. That is correct. Let's go, Victoria. So 2 to the right and 3 up. Yes? So I'm going to start with this one right here, 2 to the right, 3 up. This one, 2 to the right, 3 up. This one, 2 to the right, 1, 2, 3. And we label that G of X. You're like, what? Yep, straight up and down like that, huh? Pretty good? And why? I trigger your noodle with my Jedi Master powers because I had you write this down and I already had that in your mind before we even got started. See what I did there? Let's go, Victoria. We all are. We just need practice. All right, from 1 to 5, how come through are you with this so far? Where are we at? 4s, 5s, 4 5s, okay? So, with that said, go to the next graph paper. Write this down to the one on the right. Write example number 1. Graph G of X equals square root of X minus 3 minus 1. Write that down on the next coordinate plane. Once again, G of X equals square root of X minus 3 minus 1. Some of you are like, wait a minute, Mr. Q, but don't I need the parent function? Yeah, we'll write it down. What is our parent function, guys? What do we write? F of X equals what? What's our parent function for this? Radical X, right? Do we need a table? No, so tell your neighbor what 3 points are we going to use for this? What 3 points? 0, 0, 1, 1, 4, 2. And we label that F of X. All right? I'm going to use red for this transformation. Tell your neighbor where we're going to move this one to, where we're going to move that one to. Everyone, where we're going to move that to. 3 to the right and 1 down. So 3 to the right, 1 down, 3 to the right, 1 down, 3 to the right, 1 down. And we label that G of X. All right, from 1 to 5, what come through are you with this so far? Where are we at? Yeah, 5 4s, 5 4s. Okay. Do another one. Woo-wee. Example 1Q, change it to the next coordinate plane. Do this one completely by yourself. Completely by yourself, the whole thing. It says graph f of x equals, let me change the f of x, change it to g of x. G of x equals square root of x plus 2 minus 4. Do that one by yourself. Go. All right. Everybody got it? All right, I'm going to have Noah get us started with this one. What did you do first, Noah? You wrote down f of x equals what? Square root of x, okay. And what points did you use for that? 0, 0, and 4, 2, okay. And you label that g of x. And then what do we do next? Pass someone, Noah? Who? Okay. Yusef? 2 to the left and 4 down. Hands, have you got that? Oh, my bad. This is f of x. Yeah, I did that on purpose, see if you guys were paying attention. Nice. All right, so then we go 2 to the left, 4 down, 2 to the left, 4 down, 2 to the left, 1, 2, 3, 4, 2 to the left, 1, 2, 3, 4. And this is our g of x. Hans, have you got something like that? Yeah, we got it, yeah? All right. So, with that said, let's go back to this one right here, example number 1. Go back to that one. Everybody there? All right, this is what I want you to write. I'm going to change colors, and I'm going to want to write solve. Write the word solve, please. Write the word solve. Here it goes. Whenever they ask you to graph, we know how to graph, yes? However, what if they ask you to solve? Here it goes. Write your utensils down, look up to the screen here, you're going to miss it. Ready? Here it goes. When they ask me to solve, the first thing I do, I'm going to bring down that function, rewrite it. However, instead of g of x, what do you think I'm going to write there? Nope. Nope. 0. Copy that, please. 0 equals x square root of x minus 3, and then outside the radical, minus 1. All right? So, let's solve this. We need to leave x by itself. So what do I do here to leave x by itself? Plus 1, plus 1. We're left with 1 equals square root of x minus 3. How do I cancel that square root? Square to both sides. That is correct. So 1 squared is 1. This cancels that. We're left with x minus 3. And last but not least, how do I leave x by itself? Add 3. Add 3. So my solution is 4 equals x. Okay? So now, check this out. Look up to the screen. I'm going to show you something so that you understand what we just did. Look up or you're going to miss it. Now, this is our solution, yes? But it's our solution according to, look up, this transformation. Everybody with me? So watch. Hold on. Let me use my Jedi Master powers here. Here it goes. Look up. So this is here, isn't it? Look at the graph and look at the solution. Look at the graph and look at the solution. Tell your neighbor what that is. See if you can connect the dots. Look at the graph and look at the solution. Look at the graph and look at the solution. All right. Let's see. What do you see? Let's go with Alexander. What do you see, Alexander? The graph crosses the x-axis at what, everyone? At 4. That is correct. So, therefore, I want you to point to this spot. Put that point a little bit bigger and write where the graph crosses the x-axis, or in other words, the x-intercept, yeah? So, does everybody know how to solve? Let's go over the steps. What do? We rewrite it. Instead of g of x, we write what? 0. We solve for x, and that's how we get our solution. And what is the solution? Where the graph crosses the x-axis. All right, let's see if it's true. Let's go back to, let's go to this one. Copy the, example 1Q. I want you to write solve. And I want you to solve me that one. Solve that one, please. I'll give you some time, give you a head start, and go. Okay, here we go. For the sake of time, what is the first thing we do? We change the g of x to what? So it's 0 equals square root of x plus 2 minus 4. How do we leave the x by itself? We add 4, add 4. 4 equals square root of x plus 2. How do we get rid of that square root? Square and square. So what is square root of 4? 16 equals x plus 2. Last but not least, minus 2 minus 2, therefore 14 equals x. What does this mean? Tell your neighbor, what does that number mean? Where the graph is going to cross. So if we were to continue the arrow, we go to, let's see, this is 8, 9, 10, 11, 12, 13, and guess what? At 14, this graph is going to what? Cross right there. Woo. We're in fuego. Not bad, yeah? All right, from 1 to 5, how comfortable are you with this so far? Where are we at? 5, 5, 5, okay. All right. So, set that aside, please. Let's go back to our notes. Last problem. Write that down, please. Example number 12. Write that down, please. Parentheses, x plus 6 to the 1/2 power minus, parentheses, 2x minus 4 to the 1/2 power equals 0. Okay, watch. Look how I prepped you like 3 weeks ago. Y'all ready? Tell your neighbor what this 1/2 power becomes. Let's go. Square roots. Bring down the minus. And of course, this 1/2 power also becomes square root. 2x minus 4. All right? Next. Here goes the tricky part for this one. Let's get rid of this negative square root right here. How do we get rid of this negative square root? By adding square root of 2x minus 4 to both sides. Are we there? All right, so that leaves us with, what's on this side? We're left with square root of x plus 6 equals to square root of 2x minus 4. Next, we need to cancel those square roots. What cancels the square roots, everyone? A square here and a square there, so this cancels that. This cancels that. We're left with x plus 6 equals to 2x minus 4. You're like, this looks very familiar, Mr. Q, like the practice we did at the beginning of the school year. Of course. Get all x's to one side. Which one do I bring to the other side? The x minus x minus x. That leaves us with 6 equals x minus 4. And what's our last step? Plus 4 plus 4. Therefore, see what I did there? Therefore, 10 equals x. Yes. So we have 2 x's minus 1x is 1x. All right, we good? All right, we'll stop right there. Those of you following on YouTube, make sure you put some work in. See you guys next time. Peace.